Hey everyone, how goes it? Welcome back to Computer Science 145. Today, we're going to discuss methods. We are now going to start discussing how to organize code better. We've started writing programs where the size of the programs, the number of the statements, are becoming increasingly larger and more complex. The need to start organizing code becomes absolutely necessary. We would like to reuse parts of the code, that way we don't have to use as many statements. We also want to be able to organize code better so we can quickly find bugs and errors. And finally, we would like to add or extend functionality of programs that we have already written. All of this requires that we organize code in a better way. Everything that we've learned so far doesn't change. Basic computation, branching statements, loops, and even the basic data structure called the array, none of that changes. However, what is going to change is how we write it and where we start organizing this code. Now, as described in a previous lecture, Java structures its code first in projects, then inside of classes, then following methods. Today, we begin discussing methods. Now, methods are where we write functional code, and some of that involves where we declare and use variables such as local, temporary, or method variables, which are basically the same idea. This also goes true for branching statements and loops. Essentially, everything that we've learned before, we understand that that functional code is placed inside of a method. Now, whenever we use a method, this is referred to as invoking or calling a method. And so far, the only method that we've used is the main method. As described before, the main method is the entry point of the software. It is where the CPU knows to start reading the instructions one at a time. All of our functional code has been written inside of that main method, and this method is called by the system. Now what we're going to start doing is creating our own methods to better organize code into actions. As a programming language is essentially a language, you can think of methods as though they are verbs. They will act as the actions or the functionality that is written inside the software. Inside of Java, methods have to be written inside the body of classes. So this means within the curly braces or the body of the class. Methods cannot be defined inside of other methods, only inside of classes. Now, this is how we start defining methods, and there are several parts we need to go over in order to best understand how we can start writing our own methods. As you can see right here, this is the general formula, and now let's discuss each one of the parts. The first element is called the scope. The scope is where the method can be called. Next, that has a following return type. What value does this method return? Next, you have the identifier. Following that, you have a set of parentheses, which are the arguments, otherwise known as the parameters, for the method. What information does this method need to run? Then you have curly braces that denote the body of the method. Each one of these parts require a little bit of explanation, so let's go into that. First, let's take a look at scope. This is where the method can be called. If the scope is public, this indicates that it can be called inside and outside of the class. As you can see here, this is an example of a public scoped method, so this can be called within the class, or it can be called by a different class itself. Now, another type of scope is called private, and this indicates that it can only be called within the class and not outside of it. We're going to discuss later on about which one to use, but the main idea is a public scope means it can be called inside and outside of a class, and private means it can only be called inside of a class. There are other types of scope, but we're only going to focus on public and private in this course. The next element is called the return type. And this is a value that the method returns after it has completed. Now this can be any data type. It can be integer, double, string, even arrays. Now there is a special type called void, which means the method returns nothing. So as you can see here, this is a void return type, so after it calls system.out.println, well, nothing happens. It doesn't return anything. Now, if you do have a return type that is not void in a method, you must use the reserved word return, followed by that type of data. This means that that method is going to give that information from where it was called. As we can see right here, here's an alternate example. This time we have public, and then the return type is a string. The identifier is getGreetingString, and as you can see, this is the reserved word return. If this return type is not void, then we have to use return followed by some information. As you can see right here, this returns the string hello world. You've also used methods that had return types as well. Think about this. Every time you called the method nextInt, that method returned an integer value. So keep in mind, the return type of a method indicates what information that method is going to return after it has been called. The method identifiers follow the same rule as variables. Identifiers may only contain letters, digits, or the underscore character. Identifiers cannot contain a space of any kind, a digit as the first character, any type of dots, asterisks, or other type of special characters. In addition to that, the identifiers are case sensitive. Identifiers cannot be a reserved word, and identifiers start with a lowercase character for methods as well. It's good programming practice that if you have a multi-word identifier, that each one of the words are punctuated by using uppercase characters. As we can see here, we have get, this is lowercase, greetingString, we capitalize the G and the S. It just makes it easier to read. Also, methods should have meaningful identifiers just like variables. They clearly indicate what kind of action, what the verb is. It's a good idea when we're writing method names to use verbiage as their identifiers. So just like this one right here, we get the greeting string. Inside the parenthesis of a method are the arguments, otherwise known as the parameters. Now, parameters allow information to be given, to be passed into the method from outside of it. This information must be placed inside the parenthesis, and all of the parameters act as variables for the method, so they require a type and identifier just like every other variable. Now, multiple parameters require a comma separating them, and all parameters do require a type and an identifier. Now remember this, the scope of the parameters is only within the body of the method for which they are defined. You cannot use these variables outside of that method. We have an example here of another type of method. It's public, and now you can see it returns a type double. As a reminder, we have to use this reserved word return and return a type double. Now, what are we doing? Well, we're returning inches to centimeters. Well, in order to do this, we need to be provided information. We need to be given the information in order to calculate this. This means we need a parameter, and here it is right here, double inches. So this value is passed inside of here, and it stores that information inside of this variable, inside of this parameter, inches. Then we return this value multiplied by 2.54. Now also, you have used methods that required parameters as well. Think about any of the string methods, like for instance, dot equals ignore case. That was a method where you had to test this string by providing another string inside of its parameters. That method would return true or false if the one string equaled, ignoring the case, the other string that was given in the parameters. Keep in mind, parameters allow outside information to be passed, to be given into the method in order for it to do something. Now here's another example of a method that has multiple parameters. As we see here, we have an integer a and an integer b, and we return a is larger than b. If this is true, if a is greater than b, it returns true. If it's not, then it returns false. In this case, we needed more information in order for this method to work. So keep in mind, you can have multiple parameters for a method, and all we do is separate them by using a comma. And finally, the body of the method is where we place our functional code. Again, this is where we declare variables, and we call them local, temporary, or method variables. Keep this in mind. Wherever you declare a variable inside of the body of something is where it exists. So if we were to declare a variable inside of this method, that variable only exists inside of this method. Now this is also the place where we put branching statements, loops, and every other type of statement that we've learned so far. Now that we understand how to create a method, let's talk about how we can use them. Using a method is referred to as invoking or calling a method. Whenever a method is called, the program jumps to that method and starts running the code. Once that method has completed, it jumps back from where it was called. Now, whenever we're calling a method from inside the class where it was defined, this requires using the identifier of the method following its parameters, as we can see right here. So if we take this example down here, we have this string, str, and we assign this to getGreetingString. Now, if we start right here, as soon as we call that method, we stop and we immediately jump down to here. This then returns hello world, which then is assigned to str, and then it prints out hello world. This is also the exact same way that you've used keyboard.nextInt. What happens is every time you've called that method, it jumps to the method nextInt. It does something and then returns that integer value back. Now, if we were to call a method from outside of the class from where it was defined, first of all, that method has to have the public scope. If it does not, then you cannot call that method. Next, in order to call the method, we need an instance of that class to be constructed. Once we have constructed that instance, we use the dot followed by the method's identifier and its parameters. Now, in order to create an instance of a class, which we call an object, we go into that later on, this requires declaring a variable and then constructing it by using the word new, followed by the class type and parenthesis. Now, this is how we've always used scanner. So far, what we've seen is scanner keyboard is equal to new scanner with system.in. In order to even use the keyboard scanner, we had to construct it by using new followed by scanner. From there, we start using the identifier keyboard dot nextInt, dot nextLine, dot nextDouble, etc., etc. Now, once again, what we just saw was how we could call a method from a different class, from outside of it. But also, in addition to that, this is how we would call a method from the main method itself. Now, we cannot directly call a method from the main method without creating an instance of the class called an object. We'll discuss why that is in a future lecture. However, for now, let's take a close look at this example. Let's just assume that we had the other methods that we've previously talked about inside of this example, which was print greetings and also get greetings string. Now, as you can see here, here's our main method. In order to use any of those methods, what we have to do is create an instance of this greetings program. Notice this. Here's the type, greetings program, which matches the class. This has to match. Now, as mentioned before, if we're going to use that method, we have to create an instance called an object of that class. We do that by using the word new followed by the type greetings program followed by the parenthesis. What this line of code does is it constructs a new instance of this greeting program that we're going to call G. And now that we have this instance, we can call the method printGreetings from right here. Now remember this, when we called printGreetings, what is going to happen is this is going to jump inside of that method, which if you remember, this called a different method, and it's going to jump inside of that method, return the string, print out the string, and then come back to here. Now this concept can get very confusing as we're going to be jumping all around code. So to better explain this, let's look how methods in memory work together. First thing to keep in mind, whenever we are running programs, there are different sections of our memory. There's the stack that we refer to as the call stack, the heap, the data, which is sometimes referred to as the global, and also the text section of our code. We're going to be focusing on the call stack. Whenever a method is called, it is pushed on top of the call stack. And whenever a method completes, it is popped off the call stack. In a future course, we're going to discuss the data structure called a stack. The thing to keep in mind is a stack is a last in, first out structure. The last method that was called will complete and then go back to the previous one. This is how we can jump from one method. Once it's completed, we jump back to the previous method that it was called. Let's take a look at that. As we can see here, there's some example code. We have the call stack in memory and the console. Let's see how this is going to work. The first thing that we're going to note is the main method is already on the call stack inside of memory. Remember this, the main method is the entry point. It is where the program starts, so that is the first method that is pushed onto the call stack, and it's the last one to be popped off. So if we start from right here, what's going to happen is we're going to construct a new instance of this method tester. Now the thing is, that method tester is a special kind of method that we'll discuss in a future lecture. But as you see, that is pushed on top of the call stack, and once it's completed, it is simply enough popped off. And we move on. Once that has been called, we have created and constructed that new object that we're now just going to call M. Now we jump to this statement. Notice m.start. This is going to call the start method that is written inside of this class. So once again, the start method is pushed on top of this call stack, and so you can think of it as jumping to right here. Now this starts running the code inside of that method. So we start here, and if you notice system.out.println start, it prints start to the console. Now we move on to the next statement, which calls another method. This one is pushed on top of start, and you can think of this as jumping inside of this method, which is then going to run this statement, prints out 1. Then it's going to move down and call another method that is pushed on top of this, jumps down here, prints out that, calls another method, pushes that method on top, jumps down here, prints out that information. Now that last method, print3, it's completed. We are done with that method. Now what happens is once that method has fully completed, we remove that off of the call stack and resume back to the method that it was called from. Now we're back to print2. Well, we're done with that, so we pop that off, return back to print1. That's done, pop that off, return back to start. That's done, pop that off. Now we're back to the main method, and the main method is completed, and so we remove that, and the program terminates. Let's see this concept again, but now what we're going to do is call the methods in a slightly different way. Now let's just start right here, where it's going to call m.start. This once again pushes this onto the call stack, and then notice, we immediately call print1. This pushes that on top of the call stack, and then we immediately call print2. this pushes that onto the call stack, jumping down here, and then we call print 3, which jumps down here and finally prints out 3. Now that method has been completed, we pop it off, return back, and then we move down to the next statement, which is now going to print 2. That's completed. We pop that off, return back, move to the next statement, which prints 1. That's completed. Pops that off, returns back, moves to the next statement, prints out start. That's done. Pops that off, returns back. Now the main method has been completed. The main method is popped off, and the program terminates. By calling these methods in a slightly different order, you notice that we reversed what the console printed out. The main concepts to keep in mind is every time we call a method, that method is pushed onto that call stack. Once that method has been completed, it pops off and we resume back from where it was called from. You can think of this as we're jumping from method to method inside of our code. Now, let's see an example of this. Today, the problem that we're going to solve is we want to be able to convert certain types of units, like let's say units of measurement like inches, feet, and centimeter. We want to be able to convert from one unit to another, and so let's see if we could solve this problem. As you can see, we already have the project set up and ready to go and created the class measureConverter with the main method. Now the first thing that we're going to do is establish we're going to approach this in a different way. We're going to, instead of write everything in the main method, we're going to break this down into smaller problems and organize the code inside of methods. Remember that methods are more or less verbs, so we're going to group this every time we feel like there's a verb that we need to write. Now inside the main method, what we're going to do is we're going to first create an instance of this class measureConverter. That way we can start calling methods from the main method. So the way that we do that is we're going to first use the class name, measureConverter. Now that's a type. Now we need to create an identifier, and I'm just going to call it M. Now, in order to create an instance, in other words, construct a new instance of this class that we call an object, we assign this to new measureConverter with the parenthesis. Now this may look very familiar as we've done something very similar with the scanner. The main idea is this. When we create an instance of a class that we call an object, what we have to do is first construct that instance inside of memory. That way we can use the object's methods. Well, the problem that we have now is we haven't written any other methods, so let's start by writing a first method. Let's say that we want to just start the program. That feels like a verb. So outside of the main method, but still within inside the class, I'm going to write public void start in the parenthesis. This is where we're going to start the program. So whenever we're ready to start, we can call this method to begin the program. Now remember, whenever we write methods, first we have the scope. We made the scope public, that way we can call it from outside of this class. Next we have the return type, and this one is void, which means this method returns nothing. Then we have the method identifier, which is just start, and that describes what the method does. Then we have the parameters, which is the parenthesis, and this allows us to pass additional information inside of the method in order for it to work. This one doesn't require any additional information, so we could just write it like this. So from there, what we can next do, going back to the main method, since we've created this instance of this measureConverter, M, we can now call m.start. And so, once we've created this instance of the class that we call an object, we can call the method start, and effectively it's going to jump down here and start running the code. Now let's go inside the start method. Well, we're going to get some user input, so we still need the scanner, but this time we're not writing the scanner inside the main method. We're going to create one here. So scanner keyboard. The type scanner is a class type. We're about to create an instance of this class that we've called keyboard. Now, just like before, we assigned this to the reserved word new, followed by scanner, and in this case, we pass in the arguments, or in this case, the parameter system.in. That way, we tie together the standard system input, the input given by the console, to this object keyboard. So now that we created that, let's go ahead and greet the user. Let's print out a greeting message. Well, that feels like a different verb. So for argument's sake, I'm going to create a different method in order to do this. Entering down below the start method, I'm going to create public void print greetings. And simple enough, inside of the body of this method, I'm going to system.out.println, welcome to the units converter. Now going back to the start method, let's call that print greetings. So now, once we run this program, we start from here, we call the method start, which jumps down to here, creates a new instance of the scanner keyboard, then it calls print greetings, which jumps down here, and then the start method is done, the main method is done, and it should terminate. Let's see how this works. Sure enough, it jumped from here, created this, called this, jumped to here, that was done, jump back to here, and it terminated. Now we could have just easily had the system.out.println written right here, but we want to show how methods can be used to group together these actions. Create methods whenever a verb occurs. Now let's start writing the rest of this program. I'm going to create a boolean, call it quit, set it equal to false, and then while not quit, we're going to keep converting some information. Now, it was established from the beginning, we're going to convert inches, feet, and centimeters. So what I'm going to do is create some constants, and effectively we create the constants in the exact same way that we've done before. We're going to create them above the main method, and the first one I'm going to create is public static final string in, and this is going to be the inches. The next thing I'm going to do is the exact same thing for feet and centimeters, because these are constant values as we're converting inches, feet, and centimeters to one another. Now going back into start, we need to print out some options for the users. So they should be able to convert inches to feet, inches to centimeters, feet to inches, feet to centimeters, centimeters to feet, and also to inches. So we need to be able to print out those options. Well, once again, that feels like a different verb. As it feels like a different verb, we're going to create yet again another method. Public void print options. Inside of here, it's going to be similar to print greetings, but what we're going to do is also use those constants so it says exactly what we're expecting. Inches, feet, and centimeters, and we just print that out. Now inside of this while loop, we can call print options. That way, every time we run this while loop, it's going to give the user the options as to what they can convert. Now, we're not going to run this quite yet because right now we're going to have an infinite loop right here, but we're going to get to it in a minute. Once we have printed the options out, we now expect the user to enter the two different kinds of units. So that requires some variables. So let's go ahead and say string unit1 is equal to keyboard.nextLine. Then from there, string unit2 is equal to keyboard.nextLine. Now just to point this out, keyboard is an instance of type scanner. So this is an object that we call keyboard. We're calling the method nextLine, and what this will also do is jump to that code and capture all the information in the console until it runs into that inline delimiter and stores it back into this string. Now the next thing that we got to do is we have to remember we're only converting inches, feet, and centimeters. However, we need to validate whether or not these units are any of these. But hold on a second. Validating that input, that also feels like a verb. We need to figure out true or false is unit 1 and is unit 2 valid? So once again, we're going to create another method. This time it's going to be public. However, it's not going to be void. Remember, void is the return type that returns nothing. We want to see if these units are valid, and we want true or false, is that valid? So in this case, we're going to use public boolean is valid unit with the string input. Now this means we need to pass information into this method and then return this type boolean. So if this input is either inches, centimeter, or feet, then we return true. We can do that very simply using a compound boolean expression. So we're going to return. Now anytime you have a method that is not a void return type, you have to use this reserved word return and make sure you return this type. So we're going to return this input, this information that we're storing temporarily here and passing it into this method, input dot equals ignore case. If this equals inches, or input dot equals ignore case, let's say this equals centimeters, or input dot equals ignore case, feet. Then, if any of these are true, this is going to return true. So going back to the start method, inside the while loop, we have to validate whether or not unit 1 and unit 2 is valid before we can do anything else. Well, since we're checking this right here, let's use this method. So if it is not is valid unit, and we pass in unit 1, if that's not valid, or not is valid unit, unit 2, then inside of the body of this if statement, we're going to say one of the units were invalid, try again, and we're going to call continue, which is going to jump back to the start of this while loop. Now notice what happened here. When the user entered the unit 1 and unit 2, we are then calling this method inside of our if statement. Remember, this returns a boolean, true or false. So this unit right here gets passed into here. So this unit 1 becomes the input and it validates, is this unit 1 inches, centimeters, or feet? And then it also checks if unit 2 is either inches, centimeter, or feet. Now keep in mind, we can only use variables inside the body where they were declared. This unit was declared inside the body of this while loop. This does not exist. Neither of these exist outside of this while loop. This is why we could not just say unit 1 or unit 2 here. We had to pass that via a parameter into this method in order to evaluate, is that true or false? Whenever you need extra information given to a method, you need to write it as a parameter. Also, if you want information to be given back from the method, then make sure the return type is non-void. Now, once we have validated this, so for instance, if this was valid and this was valid, this if statement gets ignored, what we need to do then is once again prompt the user to then enter the information that we need. Well, let's make this nice. Let's format this input nicely, given the 2 units that we have. This again feels like a different verb, so I'm going to create a different method. Public void print input. And we'll just create string u1 because we need this passed to it, and also string u2. We also need that passed to it. Now using that input, we'll just print out, enter whatever this unit is, and I'll determine the number of whatever these units are. Going back into the while loop, after that if statement, which basically validates these are correct values. We're going to print input using Unit 1 and Unit 2. So for instance, if Unit 1 were feet and Unit 2 were centimeters, then this gets passed to this method where U1 and U2 is, so it would say enter feet and I'll determine the number of centimeters. Now notice, we didn't need to return anything, which is why the return type is void. Now next, we need that value from the user. Double value is equal to keyboard.nextDouble. After that, we're going to add this little fix-up, keyboard.nextLine. That way we don't get any weird bugs as we go through our program. And now we need to calculate our result. So I'm going to create another variable, double result, and I'm going to set it to 0. So now that we have the units and we have the values, what we need to do is calculate the correct data. So we need to check first, because we can convert inches to feet, inches to centimeters, centimeters to inches, centimeters to feet, feet to inches, and feet to centimeters. We need to account for all of those different combinations. So if unit 1 dot equals ignore case, inches, let's start there. If we were converting inches and unit 2 dot equals ignore case, feet. So if we were converting inches to feet, so what we need to do is calculate that result given that value. But wait, calculating a result given a value, that sounds like a verb again. So let's write this in a separate method. Scrolling down here, what we need to do is convert inches into feet. So public double. We need to do this because we need that value back. So I'm going to call this public double in to ft, inches to feet. Now also listen to what I said. Given that value. So easy enough, I'm going to create a double in. This parameter, we're going to pass this information into it and return the number of inches to feet. So as we know, all we need to do is return this number of inches divided by 12. Because there are 12 inches in every foot. And now that we have that, we can use it. Going back to the if statement, I'm going to assign result is equal to inches to feet given this value. So for instance, if the user entered inches and feet, and then let's say they entered the value 12, what's going to happen then is the value 12 is going to be passed into this method here. So value, that 12 is going to be assigned to inches, 12. 12 divided by 12 is 1. 1's going to be returned back to here and then assigned to the result. Now let's continue to do this for the other cases. Let's say that the unit was inches and the other unit were centimeters. Well, we need to calculate this again, so let's create a method in a very similar way. We need to pass this value into a method and then return the number of centimeters given this number of inches. So we just create public double inches to centimeters double some inches. Then we just return this number of inches times 2.54. Going back to this else if, we just call result is equal to inches to centimeters, passing in this value. So what we're going to do next is create all of those methods to do the conversions. The ones that we have left are centimeters to inches, centimeters to feet, feet to inches, and feet to centimeters. These are basically going to look the same. And here they are. So this method, centimeters to inches, you pass in a number of centimeters and then it multiplies this by the conversion. Centimeter to feet does the exact same thing. Feet to inches, same thing. Feet to centimeters, same thing. Now using all of those, we can scroll back up here and account for those different combinations, which we have here. So now, if the user entered centimeters and inches, we basically call the method centimeters to inches, pass in the value, get the result. Same thing for centimeters and feet, feet to inches, and feet to centimeters. Now there is one last case. So we're going to put the else there, and we're going to just assign the result equal to the value. This would be kind of a funny case where if someone wanted to convert inches to inches, then it's just the value. Now once we've done that, we need to print the results. Once again, printing out the results feels like a different verb, so we're going to create another method to print out the results. I'm going to go below print options. Public void print results. Now in order to make this nice, we should be able to say what unit that we were converting it from, converting it to, and also the value. That all feels like different parts of information that we need to pass in, so they should be different parameters. So in this case, what we're going to do is we're going to string U1, string U2, unit 1, unit 2, and also the double result. Now inside this method, we're just going to print out there are the result of this units in these units. Still within our while loop, but right past that else statement, we're going to call print results, where we pass in the first unit, second units, and then the result. Now to finish out this program, we're also going to then prompt the user enter to keep converting the units, or enter quit to quit. Then we basically reassign that boolean quit, whether or not the keyboard.next line .ignore case is equal to quit. And if they did choose to quit, then outside of the while loop, we just say goodbye. Now scrolling up, I'm going to put this into focus, and we're going to go ahead and test out this program. So now running this, we see we prompt the user, and we can enter either inches, feet, or centimeters. Let's go ahead and try inches to centimeters. And let's just say, I don't know, something simple. Well, let's just put 1. Well, this looks correct. There are 2.54 centimeters in inches. Now let's try it again. I'm just going to press enter. It comes up with this again. Let's try feet to centimeters. Let's say 2 feet, and there you go. Let's try an error condition. Let's say we were converting inches to miles. Well, one of those were invalid, and we try again. Let's try centimeters to feet, and let's try 30, and there you go. I'm going to go ahead and enter quit, so it ends the program. Now you may have noticed that this seems like a lot of extra code to write, but this is much better organized code. This helps us find if there's errors inside of the code and quickly figure out where it may be coming from. Using methods help us group together functionality into verbs. And every time we call a method, effectively what we do is we jump to where that method is, run this code, and then we return back. And with all that being said, I'll see you next time.